Hi, my name is Karthik Raja, and the project that I'm going to be presenting is Deep Learning for Age Prediction. To give an overview about the project and why age prediction is important, age is one of the vital factors which establishes on how the level of tolerance and other social parameters are determined and altered within human beings. And also, age prediction has many applications ranging from security, image retrieval photo verification, which is the photo verification in an individual's passport, and also for finding the missing person by matching their photograph with the one available in the missing person database, thus localizing the manpower search to a particular age group rather than a vast spectrum. Age prediction is done through analyzing the facial features of an individual. For this task, the problem statement is that there is a need to predict age of an individual by analyzing the photograph of the said individual. The solution that we propose utilizes deep learning techniques and convolutional neural networks to predict the age of an individual from photographs. For this said task, we use Morph database because it contains 55,000 images, so that it is sufficient to train the model effectively. And one of the uniqueness of this dataset is that the age range of the individuals in this database is from 16 to 77, with a median age of subjects to be 33. The average number of images per subject is 4, and the average time taken between each image is 164 days. Based on various age groups, we assign labels starting from 0 to 9, which will be seen in the later slides. The pre-processing involved for this task is dimensionality reduction. So we do dimensionality reduction by utilizing OpenCV. The image is resized from 400 cross 480 to 224 cross 224 initially, and it is converted into grayscale. After this step, we use cascade classifier to detect the face by using contours and bounding areas. Then the image is resized to 120 cross 120. In this slide, it is seen what the pre-processing step actually does. First, the image is resized to 224 cross 224 and it is stored in an image variable, and then it is converted into grayscale and stored in a gray variable. Then cascade classifier is applied and then it is resized to 120 cross 120. Resizing or the dimensionality reduction is done to overcome the computational constraints that might arise during the training phase of the task. The system architecture for age prediction task involves convolution layers, which are commonly referred to as CNNs, fully connected layers, max pool layers, which are used for dimensionality reduction, ReLU activation layers, 3 cross 3 filters, which are also referred to as kernels, ensemble technique known as batch normalization, and softmax layer, since there are 10 classes ranging from 0 to 9 involved. Determining the number of layers of the model depends on experimentation, and through experimentation we have designed a 10-layered deep neural network model which is effective in determining the age of an individual through photographs. So filters, usually referred to as kernels, acts as a group operator. So here in this picture we see a 3 cross 3 convolutional filter or kernel. So it moves across the entire image, picking up the important features, thereby reducing the output volume size and giving it to the next layer that is involved in the architecture. So by using the filter, the image size keeps on decreasing and the depth keeps on increasing if we increase the number of filters as the image progresses throughout each layers of the system architecture. The output volume after each layer is calculated using the formula seen in the slide, which is n minus f divided by stride plus 1. So n represents the input dimension, f represents the filter dimension, which is 3 cross 3 that is used, and stride represents the number of columns moved by the filter in an instant. So for this application we use 3 cross 3 filters except for in the first layer, which we will be seeing later. So going into the architecture specifics, as said in the previous slide, the first layer has 64 filters, hence the depth criteria is increased to 64 for the next output volume. Here we use 1 cross 1 filters or kernels since it is just an identity layer. For the remaining layers we use 3 cross 3 filters with increasing number of kernels. Since we increase the number of kernels, the depth of the output from each layer keeps on increasing. So we use 64, 128, 256 and 384 kernels after every 2 CNN layers. So we do not employ padding technique since we already use filters and a technique called as max pooling for dimensionality reduction and picking out the important features. So if we use the concept of padding, we will be downsampling the image further. Hence we do not use it over here. As stated, max pooling is one of the techniques that is used to reduce the dimensionality of an image by selecting the important features alone. If we look at the picture in the slide, it is a 4 cross 4 matrix. Let's consider that to be an image. So if we apply a max pool layer of 2, say dimensionality 2 cross 2 with a stride of 2, for the first 4 cells, 2 row and 2 columns, which is represented in the pink region, the max pool layer only selects the important features. Hence 6 is selected out of the first 4 cells. Then out of the next 4, 8 is selected. Then beneath 3 and the one towards the right of it, 4. So max pool layer only selects the important features from each layer. If we look at an image, even the edges are can be detected through max pooling layers. So diving in more into the architecture specifics, we use an ensemble technique called batch normalization, which follows the max pooling layer in the designed architecture. Batch normalization makes the mean value of the input to be 0 and the variance to be 1. This is done in order to boost the performance, and mean value and variance is set to 0 and 1 respectively. Thus the internal covariate shift is normalized by regulating the feature map values to be restricted to just the z-axis rather than any others. Batch normalization is used along with max pooling after every 2 layers. Fully connected layers are used at the end to achieve global connectivity of an individual maps. And another ensemble technique called as dropout is implemented to boost the performance of the model. Dropout is an ensemble technique where we drop certain number of neurons at random during each iteration in the forward pass to boost the performance. We have used 50% dropout, which we will be seeing in the later stages as we go through the code. The last layer is the softmax layer, and we have 10 classes. That is the reason we are using softmax layer. The 10 classes start from 0 to 9. As stated earlier, we have segregated different age groups into different classes. So age group 16 to 18 as class 0, 19 to 21 as 1, 22 to 24 as 2, as it goes on. Since the dataset consists up to 77 age group of individuals, we obtain 9 classes. So this is the system architecture. First we give the input to the first 2 CNN layers with 3 cross 3 kernels, with the first one being 1 cross 1 since it's identity layer as we saw earlier. Then comes the max pooling layer. We apply 2 cross 2 with a stride of 2. So the dimensionality is reduced by a factor of 2. Then comes 2 CNN layers followed by a max pooling. This keeps on repeating for a few more layers. The final is the fully connected layers, where dropout is being implemented to boost the performance. The softmax layer consists of 10 classes with 0 to 9 as seen earlier. So each layer has neurons associated with it, with which transfer information to each and every other neuron in the following node, and it obtains information from each neuron in the preceding layer as well. The weights are initialized according to the paper that is mentioned in the slide, because that paper got the best performance by optimizing the weight initialization. The learning rate of the model is set to 0.01. During the training phase, if the training curve plateaus rather than converging to the global minima, then the learning rate is further decreased. The optimizer for the learning rate used is ADAM, which is a combination of adaptive gradient and momentum techniques. The batch size is 30 and the loss function used is categorical cross entropy. Since there are multiple classes, we use categorical cross entropy. If there are much less age groups, say 2, we would have been using binary cross entropy. So during the forward pass, the information transfers from each and every node to the last one, and then through back propagation, it traverses the same path in the back direction by computing the gradients and then by adjusting the weights. So the loss function is obtained by subtracting the actual minus the predicted. So based on the cost function, we change the weights and then optimize our architecture through each and every iteration. So this slide shows the CNN model that is written in Python language. So since it is a sequential process, not a parallel one, the first line is seen, it is established to be sequential. Then we use a convolution layer. The input size is 120 cross 120 as stated earlier with 64 neurons. The activation layer used here is ReLU. Previously many papers used sigmoid activation layer, but due to the characteristic curve of the sigmoid layer, the saturation happens in the positive region and also it is non-zero centered. So we opt for ReLU activation layers. So this code mimics the system architecture that was actually shown 2-3 slides before. Here you can see the number of neurons that are actually assigned in each and every layer. The number of neurons actually increases as we progress. The 384 is the number of kernels, the 3 cross 3 kernels. 128 is the number of kernels as we seen in the previous slides. As stated earlier, the dropout is implemented at 50%, which is 0.5, to boost the performance. So this is how the flow of the entire architecture takes place. So we first train on the MORPH database, then the user uploads the photo onto the trained model. So we get an age prediction, which is the classes from 0 to 9, which determines what age group that the individual whose photograph was uploaded belongs to. Here is a more pictorial representation of what was said in the previous slide. If you look at the picture on the right side, it is seen once if we upload the same picture in the system architecture, we obtain the result that this individual age group belongs to 29 to 32. The performance metric that we use to analyze this task is accuracy, and we employed 5-fold cross validation. As stated earlier, we experimented with different CNN layers, the first one being 4 layers followed by a 7 layer, and lastly we finalized on a 10 layer where we got the best accuracy. For the 4 layer CNN we got the accuracy to be 64.81. For the 7 layer CNN we got it to be 72.35. For the 10 layer we got a better accuracy for 82.7%. Based on all these three architectures, we suggest that the 10 layer CNN has better capability in predicting the age group of an individual. The advantages of using CNN rather than conventional techniques is that in techniques other than convolution neural networks, the features essential for the prediction need to be localized and individually and precisely identified. There is no need to select each feature individually if we use convolution neural networks. And if the images are not focused properly, then the learning the features during the training phase becomes a tedious task. So if we use CNN layers or CNN architecture model, we would not be encountering this limitation. The limitation that was stated above can be overcome by using Gaussian mixture model, but the Gaussian mixture model is good only when the data set is small without vast scalability. So these are the references that have been used for the completion of this project. Now let's look at the code that is actually involved in designing this architecture. So we use the Keras library, which is predominantly used for coding in the Python language. So we import various packages. So as stated earlier, this is a sequential process. So we are importing that from Keras model library. So from the layers aspect of Keras, we import the dense activation, dropout, and flatten functions, and hence we import all the necessary aspects. We import all the necessary aspect for the efficient functioning of this architecture. First, during the pre-processing phase, as stated earlier, we first read the image and then resize it and use the cascade classifier and then resize it to 120 cross 120. So these are the code that is actually involved in the entire pre-processing phase, but these 4 codes are actually the most important and predominant one. Then we move on to the model layers. So we saw the same code before during the slide itself. First it's a sequential process, and then we use 64 kernels in the first layer, and we use 1 cross 1 kernels since it's an identity layer. Then we use 3 cross 3 filters or kernels, and then the number of kernels keeps on increasing with each convolution layer. So the max pool size is 2 cross 2. The number of rows, the dimensionality is reduced by a factor of 2, and patch normalization and dropout are the ensemble techniques that we discussed earlier, which are used to boost the performance. Yeah, and the loss function is categorical cross entropy, and the optimizer is Adam. So right now, for the age prediction task, we think deep learning is one of the most effective tools in predicting the age. We haven't localized to a particular age in this project, but we have localized the photograph to a particular age group, which can be further added on and improved during later phases of the study. So the best accuracy we obtain for this architecture is 82.7%. Thank you.